Welcome all to my third tutorial of Biostatistics. In this tutorial, I'll be talking about the measures of central tendencies. Generally, it is found that the values of the variable tend to concentrate around some central value of observations of an investigation which can be taken into consideration as a representative of the whole data. And this tendency of distribution is known as central tendency. Measures of central tendency we commonly say as average also, and the measures of central tendency give us an idea about the concentration of the values in the central part of the distribution. The measures of central tendency is broadly classified into mathematical average, average of position and partition values. Here you can see the details of the classification of the measures of central tendency, and the mathematical average is classified into arithmetic mean, geometric mean, harmonic mean and quadratic mean, and under the average of position comes the median and mode. And in this tutorial I'll be talking mainly about the arithmetical mean. The central value or average obtained arithmetically is known as the arithmetic mean. Simply, arithmetic mean is average, as I said earlier. Commonly we say average for arithmetic mean. And arithmetic mean is of two types: simple arithmetic mean and combined arithmetic mean. First, we'll be discussing about the simple arithmetic mean, which we commonly use in all the experimental purposes. Then, simple arithmetic mean is commonly used to find the arithmetic average, and it is a value which we get by dividing the aggregate of various items of the same series divided by the total number of observations. And simple arithmetic mean, first we'll see how we find the simple arithmetic mean of a ungrouped data. If the values of n items, number of items is n, are x1, x2 till xn, and then the simple arithmetic mean is obtained by dividing the sum of all the values, that is x1 till xn, divided by the total number of observations, that is x bar. Arithmetic mean simply x bar is equal to, usually we denote by x bar is equal to, you can see the equation here, x1 plus x2 plus x3 till xn divided by the total number of observations. That is simple arithmetic mean for ungrouped data. This is a question of ungrouped data, that is the hemoglobin percentage of patients suffering from AIDS, and this is actually a hypothetical data, and the formula which we this is a ungrouped data. It is not grouped on any criteria. This is ungrouped data, and in this data we apply the simple arithmetic mean equation, that is x bar is equal to sigma x divided by n. X bar is equal to sigma x divided by n. And from this data, sigma x, how we calculate sigma x? I said it is x1 plus x2 plus x3 till xn. So here it is 5.2 plus 5.3 plus 5.6 plus 5.7 plus 5.4, 5.2 till the last value. 5 plus last one is 5.2, the whole divided by n. N means total number of observation, and here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 observations we have here. So the total divided by 10, and the sum of all these numbers comes to 53.6. 53.6 divided by 10, that is equal to 5.36. 5.36 mg per 100 ml will be the mean arithmetic mean of this data. This is an ungrouped data, and this is how we find. For ungrouped data, the equation which we apply is sigma x divided by n. Now, next we will see how to find arithmetic mean for grouped data. Group data can also be of two types. It can be of discrete series or it can be of continuous series. So first we'll see how to find the arithmetic mean of grouped data which are of discrete series. Discrete series. Discrete series, that is grouped data. In the previous tutorial, we have explained about how to write a frequency distribution table based on frequency with class intervals, etc. Then, discrete series means if the data is in frequency distribution but not in class interval, then it is called a discrete series. For computation of the arithmetic mean of a discrete series, each value of the variable is multiplied by the respective frequencies, and sum of all values obtained is divided by the total number of frequencies. Let's see the value of variables if it is x1, x2, x3 till xn, and these are the variables, and corresponding frequencies it is f1, f2, etc. till xn. Then the arithmetic mean x bar is equal to frequency of the first variable with its corresponding variable plus f2 into corresponding variable plus till fn into corresponding variable, the whole divided by sum of frequencies f1 plus f2 till fn. Here arithmetic mean is equal to, we consider frequency and the variables together. So the variable here is x1, x2 till xn, and the frequency is f1, f2 till fn. So it is f1 into x1 plus f2 into x2 till fn into xn, the whole divided by sum of the frequencies. That is equal to, the equation which we apply here is x bar is equal to sigma fx. Sigma fx, the whole divided by sigma f. This is the equation which we use here. And now let's see an example. The example given here is the rate of respiration of 43 fishes and their respective frequencies in the table as follows. And let's see how we find the arithmetic mean. This is the table. The first step, what we have to do is, this is the question. You can see here you have rate of respiration and the frequency in the tabular form. First step is to make table with variable, frequency and frequency into that variable. That is, we have make a table with 3 columns. 1, 2 and 3. The first column is for variable. The table is showed here. First is variable, then next is frequency, and the third column is variable into frequency. Variable into frequency, that is f into x. This is x and frequency f. From the table you can write, that is the rate of respiration, that is the variable. These are the variables and this is the frequency. Rate of respiration, that is 2, 16, 20, 30. It goes on like that, and frequency is 3, 4, then 7. So here you have to rewrite this table. This is the question, and you have to rewrite the table with 3 columns, variable, frequency and frequency into the variable. Here it is, the frequency is 3, 4, 7. It goes on like that. I have written the complete, you can see the complete table here. You have to arrange the data like this, and here frequency into variable. So what you have to do is multiply 3 with 2. 3 into 2 is the value which comes here, that is 6. And here you have to multiply 4 into 16. That is equal to 64. And here you have to multiply 7 with 20. 7 into 20. That is equal to 140. And the complete table has to be completed like this. And finally, after completing the table, you have to find sigma f. Sigma f is the total of the frequencies here. That is sigma f. And here also you have to find sigma fx. The complete tabular column is given here. It is split into 3 columns. The sigma f is 43 and sigma fx is 1672. So x bar is equal to sigma fx divided by sigma f. And the value is given here, that is 1672 all divided by 43, and the answer is 38.88. That is how a discrete series data is handled for calculating the arithmetic mean. Now let's see how to find the arithmetic mean of the data with continuous series. In the case of grouped continuous series, the arithmetic mean is calculated after taking into consideration the class interval. In the previous tutorial, I've mentioned about how to make a frequency distribution table, how to find the class interval, the class boundaries, midpoint, etc. And equation which we apply here is x bar, or the arithmetic mean, is equal to sigma fm divided by sigma f. And m stands for mid value of the class intervals. And let's see how to find the mid value. Mid value or m is calculated by adding the lower limit of the class interval with the upper limit divided by 2. Say for example, if the class interval is 10 to 20, the midpoint, mid value or midpoint is 10 plus 20 divided by 2. This is the mid value. This is how we calculate the mid value. So, example you can see here, the question is the rate of respiration of 50 fishes of a species and their corresponding frequencies. And let's see how, and in this question we have to rewrite the table into a table with 4 columns. First with class interval, 4 column table, 2, 3 and 4. First column with class interval, second column with midpoint or mid values, third with frequency, and the fourth column is mid value multiplied by the frequency. And the question you can write here 1 to 10. We'll rewrite 1 to 10 is the first class interval, 11 to 20, 21 to 30, 31 to 40. Then the mid value is 1 plus 10 divided by 2. 1 plus 10 divided by 2 is the mid value. The mid value of first class interval, interval is 5.5. Here, next is 11 plus 20 divided by 2. The value is 15.5. And here, 21 plus 30 divided by 2, that is 25.5. Likewise, you can complete the table. Then corresponding frequencies are 3, 11, 7. It goes on like that. And in the fourth column, you have to multiply mid value with the frequency, that is 5.5 into 3, that is equal to 16.5. Then here again mid value has to be multiplied with the frequency. So 15.5 multiplied by 11, that is 170.5. Here also 25.5 into 7. Likewise the table has to be completed, and sigma f has to be calculated. Its sigma f is the total of all the frequencies in this column, that is 3 plus 11 plus 7 plus 4 plus 10 plus 5. Have to complete it, and that is sigma f. Sigma f is 50. Then mid value, the total of the mid value is 1925. You have to add all the values in this column, that is m into f, total of all 16.5 plus 170.5 plus 178.5. The table you can see here, the whole divided by sigma f, that is 50. That is the answer for this question. This is how you find the arithmetic mean. Now let's see how to find arithmetic mean of combined arithmetic mean. If x1 and x2 are the arithmetic mean of two series, x1 and x2 are the arithmetic mean of two series whose number of terms are n1 and n2. Two series whose number are n1 and number of terms are n1 and n2. Then the combined arithmetic mean x bar is equal to n1 into x1 plus n2 into x2, the whole divided by n1 plus n2. This is a combined arithmetic mean. We can see a question here showing the mean length of 40 earthworms is 65 centimeter, and the mean length of the other group of 50 earthworms or 50 earthworms is 60. And it is to find it, you have to multiply 40 with 65. That has to be added with 50 into 60, the whole divided by n1 plus n2, that is 40 plus 50, and the answer is 62.2. The answer is shown here. And now let's see what are the merits and demerits of arithmetic mean. The merits of arithmetic mean, it can be easily calculated and it is easily understood. Easily calculated, easily understood, and that is the reason why it is most commonly used for the research purposes, especially in biological research. Then second is, every item in the observation is taken into consideration for finding the arithmetic mean. Then the formula for finding arithmetic mean is a rigid one, so the result remains the same. Then another merit is the calculated quantity is not based on the position of the value, but it is a total of all the observation which we get. Coming to the demerits, it is obtained mean in a series and it cannot be located graphically. It cannot be located graphically, and if a single item change from the observation which we get, if we change a single item from the data, the whole value will change. For example, 4 plus 3 plus 6 is the initial value which we get, and after some time if we are changing the 4 with another value, that is 40 or 20, the whole result will be changed. That is another demerit. You cannot change the data or observation after finding the result. The whole result will change. Then its value will be effective only when the frequency is normally distributed. Otherwise, skewness is more and the results will become more ineffective. And about skewness, correlation and all we will discuss in the coming tutorials. Thank you very much for listening.